Now, let's see an example of how to apply a PRA, or Probabilistic Risk Analysis. For this, you can think, for example, of all the times that you arrive late for work and you want to solve it by thinking of an event tree model with different possibilities and different branches, and calculating the different probabilities. You can figure out how to improve your performance. The initiating event in this case is being in a work day. And also you have mitigating systems in form of a clock and a backup person that can wake up you if the other system fails. The main idea here is to solve the model and to calculate an estimated career damage frequency by calculating the initial event frequency and determining for each of the branches of the model their probabilities. First, we set the different events. The first one is if we are in a work day. Then you have your first mitigating system in form of the clock. Then you can, as an operator, listen to the clock or not, and to answer to that alarm. And finally, you have your backup person as the second mitigating system. Let's see how our tree model works. First, we have that every time that we find a branch, we are going to have the successful situations at the top and the failures at the bottom. The first branch is going to be if the alarm rings. The second branch depends on if we listen or not listen to the alarm. And finally, the third is regarding the backup person when the clock fails, or we do not respond to the alarm. Let's calculate the frequencies. First, we can say that each year has approximately 250 work days per year, based on an average 5 days per week and 50 weeks a year. Based also on our experience, we know that when the clock alarm works, we listen it 90% of the times, and we fail to respond to it 10% of the times. We also know, based on past experience, the performance of the backup person. This is the operator action regarding human reliability analysis, or past experience. Next, we have that the operator action regarding the backup person. The probabilities here are different from the previous ones. But there is another probability that we need to know and calculate, that is, how many times does the alarm fail? Let's calculate. For solving this, we can do a diagram with the main three probabilities that affect the alarm, like setting incorrectly or not setting the alarm, having electrical power losses or blackouts, and finally, that the alarm clock fails for whatever reason. That is not included in the first two. So, based on our experience, we know that we do not set properly the alarm 4 times each work year. So we have approximately 0.016 times of doing this. Then we know that by our experience, once again, we have electrical power losses 3 times each work year. with a probability of 0.012. And finally, the clock company experience data says that the failure is 1 in 10,000 demands, which is a very small probability. We have all these, and if we calculate the overall failure probability, we have approximately 3% of the times, using the rare event approximation and adding the probabilities under an OR gate. So now we know the probabilities for failing the alarm, and we set it here. Now we know the frequency of being late because the alarm fails, we do not respond to the alarm, and our backup person fails too. That is approximately 2 times per year. Also, we can calculate the frequency of being late due to the failure of the two mitigating systems, and we set it in 6 times a year. With those two probabilities, or frequencies, sorry, we can calculate our career damage frequency. That will be the sum of both. 8.4 days late for work per year. Now, let's think that you add another clock. How does the career damage frequency change? So please, calculate your career damage frequency for that case. Consider that all the probabilities regarding you responding the alarm and the backup person failing to wake you up and the possible clock failures are the same. Answer to this question in the next slide.